Sir, shall
We can start, no?
yeah, please start. We'll adhere to the timing. But we're joining one after the other. Please start.
Yeah. So I was discussing about the correlation regression topic. So where we have seen that the importance of correlation as well as the relationship regression in yellow belt journey. So why it is required is because I want to model the process and I want to see which X is important for me. So as I was mentioning, R square is your measure of parameters which we measure in linear regression for finding to know that whether my model is accurate or not. So if it is accurate, how much accurate is it? If it is zero point 0.9 means it's a good accuracy model. 90% 98% is accurate. Accuracy is good. If it is zero point 0.8, 80% accuracy is good. That means 80% of the variation which is captured by the y on x. That is the meaning. So let us take one example, then I'll demonstrate you how we use the model of linear regression in yellow belt for identifying the important factor. So there is ABC industry has taken a project to improve the dimensional variation of CNC machining process in production of hydraulic cylinder. Again, hydraulic cylinder example I'm taking because same example I'm taking because to understand how the Six Sigma journey will help in finding the solution. So during the brainstorming, two potential causes identified: depth of cut on bore diameter, and cutting speed also is there. So here only I mentioned depth of cut. So, but causes only depth of cut they are identified. To identify the root cause from the potential cause, engineers have collected 16 data on bore diameter in CNC machining process. That means design of experiment they have done, 16 data, 16 experiment they have done, and they have collected the data. And verify whether these factors is a root cause using correlation method and compute the correlation coefficient and develop a linear model and interpret the result. That is what the question is asked in the question. So let us see this LR exercise 1 Excel sheet. LR exercise 1 Excel sheet, yeah. See here, again the same data. There are 16 experiment has been conducted, depth of cut and cutting speed. So here it is. I'll take only depth of cut. Only one variable I'll show first, and then followed by the two variable. So the suppose if I am what they identified, depth of cut they identified, no depth of cut they are identified as a root cause. Let us see whether it is a root cause or not. So I will take this data, that is means x1. This is my x1. This is my x1, and this is my y. That means the output of the system and input of the system. So I'll take these two columns only into the Minitab. Directly I'll show in the Minitab itself. So here I'm pasting the data. So anyway, this is not required. Anyway, it is there. So the depth of cut is x1. That is the 16 experiment has been conducted, and on the bore diameter is your output. Since here both are continuous, no, both are continuous. X1 is also continuous, y is also continuous, output also continuous, input also continuous. So if such a case, the scatter plot will be used for identifying the relationship. Okay, that we have done already. And we have found the depth of cut was the root cause. That also we have found in the previous example. Now directly I will go for correlation analysis, isn't it? Because the first step what we do is we summarize the data and type of the data. Continuous data, bore diameter is a continuous data. So therefore categorical in nature, any of the one of the categorical. Of course, if suppose bore diameter is quality of the bore diameter, good bad, then I should use logistic regression, not this simple linear regression. So that is another type of regression, logistic regression. Then scatter plot we already done, and and you have seen that depth of cut is a positively correlated with the y. So therefore it is a root cause. From the graphical analysis, a root cause. Now let us check from the analytical technique whether we will find the root cause or not. And if it is so, then what value of depth of cut I need to set in the machine? So our optimal setting of the depth of cut also we can find out. So let's see first correlation analysis, and then followed by the regression. So first we'll find out the correlation, because I know that there is a correlation from the scatter plot analysis, but I want to find out quantification of that value, the degree of correlation. So how good that correlation is? Is it a 80% degree of relation, or 90% degree of relation, or 70%, or zero, or minus 40%, minus 60%? That I don't know. That I need to check now. So for that, we should go for correlation analysis. So here the correlation analysis, go to start, basic statistics, and here is the correlation. Covariance also we can do, and correlation can also be done. So click correlation, and then we'll find out the relationship between the two variables. Here I want the correlation between x and y, depth of cut and bore diameter. I want to know what is the correlation value, and here I'll choose Pearson correlation method only, not this Spearman row method. Most of the research we use Pearson correlation only. Spearman row also some people use for finding the relation, but in most of the research papers, Pearson correlation only we use, and display p-value also, and okay. Now you can see the result is obtained here. The Pearson correlation of depth of cut versus and bore diameter is 0.897. Very good. R is equal to 0.89, 89.7% of degree is they are correlated each other. That means so they are very positive, uh, approximately strong correlation between depth of cut versus bore diameter. That's what we are seeing in the scatter plot also. This scatter plot, this value was difficult to get from the scatter plot, but from the correlation analysis, we are able to get the value, exact value of degree of the between the relationship of x1 and y. And p-value also is equal to 0 0.0. That means is okay, it is acceptable, that it is a higher correlation it is. If it is p-value is more than 0.05, then definitely your correlation will be very very nearer to zero. If it is equal to or less than 0.05, so we can expect that r value will be higher. Higher in maybe positive side, or higher maybe negative side. But if it is p value is greater than 0.05, then obviously chance that that relation is not a relation, that it may be closer to zero. So we do not know. So since we can say that there is a positive relation with a 89.7 degree of a relationship, or strength of the relationship. So this is the first step. Second step, we will model it. So we'll model how to do start, regression, fit regression model. So here it is asking the response. So what is the response is? Here it is the terminology in Minitab uses response, but in the real practice is output. Output is bore diameter in my case. And what are the input? Input in nothing but depth of cut here. Only one variable I'm taking for the time being. If I'm taking two variables, then it is a multiple linear regression. So it is a single linear, simple linear regression I'm explaining. And categorical variables are not there. I do not have like low, medium, high kind of data, right? I should not use. Sometimes it may also possible that if your axis may be having categorical, but y is continuous, then you should use linear regression. But if your y itself is a categorical, and x may be either categorical or maybe continuous, you should use logistic regression only. I repeat again, if y is your categorical, means quality, good quality, bad quality, good quality, bad, output is categorical, irrespective of the axis, input is categorical or continuous, we can use logistic regression. But whereas in case of, it may also possible that your speed is low, medium, high, and y is your MRR, then we can use categorical variable predictor here. Here the option is available in Minitab. we can use continuous variable as well as categorical variable. Here I do not have any categorical variable, but depth of cut is having the continuous variable. So therefore I have chosen as a depth of cut. Okay, and then stepwise here in model there is nothing to be changed. Okay, because only one variable is there, no need to change anything. And in graphs, yes, we can put all the graphs in one window only. And then stepwise regression, there are three types are there. One is called as stepwise forward selection backward elimination method. There are different types of linear regression only, but will be used for different purposes. So most of the cases one can use the stepwise or none. For the case of single variable, none is enough. For the case of two or more variable, you should use stepwise. Okay, so stepwise means it will remove the variable from the model. Okay, so if there is that variable is not significant, so automatically the stepwise method will remove that variable from the model. Okay, since it does not matter in this case because only one variable I have, one input I have. So it does not matter whether you choose stepwise, whether you choose backward, whether you choose forward, whether you choose none. Nothing much difference will get. Okay, say okay. And then result, everything will be same, fits diagnostic and say okay. So now the result is displaying in the session window. Now you can see here there are three tables. From this onward, that we have to read the regression. So here the first is regression ANOVA. ANOVA analysis separate, regression ANOVA is separate. I'll repeat again. ANOVA analysis is separate, regression analysis ANOVA is different. See, ANOVA is separate and regression ANOVA is separate, isn't it? So is the analysis of variance of regression, regression analysis of variance. So here it is a regression model will be there. The model value you have to check. The model accuracy is overall the model accuracy is very good because its p value is zero, isn't it? P value zero is nothing but always p value will not be zero, but if it is less than 0.05, then we say that our model is good. Good, right? Then variable also we check the p-value. That p-value is again zero here. In this case is zero because it's a hypothetical data. It is not actual data. So since it is a zero, but if you collect actual data and if you analyze, you may find a difference also. So zero means it is very good, less than or equal to less than 0.05 is meaning is that the factor is a significant. Here we say that depth of cut is a significant factor. That's what in the scatter plot also we have seen. Scatter plot was we found that depth of cut was a root cause because it is an increasing trend. So that is validated here from using an analytical method. A depth of cut, yes, really it is a root cause because its p-value is less than 0.05. So then on top of that, we need to check the model summary here. That is R square value, as I was telling about that. That is R square value is 0.80. I mean, sorry, 80%. 80.41 is a good enough. That means more than 80, sometimes we refer as a reasonably good model. This model can be used for prediction also. Okay, so that also will check. And adjusted R square, we should not check now because it's only one variable I have in my model. So no need to explain about adjusted R square here in the research paper if you have only one variable. So one variable means only you have to highlight about the R square value in the research paper. And prediction research R square, predicted R square is basically 75%. What does that mean is 75% chance that, or maybe 75% accurate result the prediction value it will give. Okay, still 25% not believeness is there in this because we cannot believe 25% there is an error is possibility in prediction. What is that meaning is suppose I have kept 130, right, and I got 35. So it's not guarantee that when I'm keeping 131, suppose 131. So next time from the experimentation, I got 36, but you may not get 36 on the analytical model. So approximately 75% of prediction capabilities. only 75% of the prediction capability. So you may get maybe 35.4 or maybe 30, 34, something like that. So for a different value of x. So that is a capability of 75. If higher value of prediction, you can say that this model equation can be used for prediction purpose, surety. If it is a R square prediction is 98, that means 98% of the times or percent of accurate in prediction of the model or values of the output. Here 75% of prediction of the values in the output. That is the meaning. The coefficient is given here. The constant is, as I was mentioning, alpha. Alpha is this minus 81.6, and this is beta is 0.906. It's a coefficient. By using this coefficient, we can formulate the equation. That means minus 81.6 plus beta times depth of cut. That means beta into x1. So this coefficient will change again and again when you change the data. If your data is same, then coefficient will be same. Now by using this equation, we can do many exercises. Many exercises in this, what different value of x, we can find out the y value. So I want to know 135. At 135 x1, what is the y value? No need to perform any experimentation. It will give. Within the range, it will give. Within the range, the accuracy of giving is 80%. Right. But you want to do extrapolation. Extrapolation means sometime it may be out of the range. It is difficult sometimes. The prediction will give approximately only 75%, something like that. But generally, we will not use much for that. We use some other heuristic methods for prediction purpose and all. So here the coefficient is minus 81.6 and 0.906, and depth of cut is x1. So and this is the way we have to read the result of the regression analysis. Okay. Next one is these graphs. These graphs is nothing but normal probability plot. The first plot is a normal probability plot. This normal probability plot shows the information that whether data is having fitted well or not. That means if the data is closer to state line, that means it is showing that the data is perfectly fitted the model, fitting the red line, because this red line is a fitted model, fitted line, and all the data are very closer to the red line. So somewhere here is something error is there, and that error is captured by that 80%, whatever we say. No? If you have, and all data are on the line, that means it is 99. R square will be 99 or 98, or exactly line on the line means 100%. R square will be 100%. So that may not be the case, because if you are showing in a result in a research paper that R square is 100%, that means you have manipulated your data. Because in real practice in CNC machining process, any type of process, if you see, noise will be there, error will be there, operator error will be there, material change will be there, vibrations will be there, environmental effect will be there. So exactly getting is highly impossible. And if you're getting means it is something an indication that you have manipulated a data, or maybe very highly accurate process it is. But still, if it is highly accurate also, you may get at least 99.8, 99.5, or 99.2, 99.3. So slight difference will be there. So that fitting exactly line on the line means something like you have manipulated the data. So this is the graph. So histogram, it shows that the residuals means errors, the fitted values and experimental value is plotted here. This is called residuals. And the residual, if you connect the edges, no, approximately it is following the normal distribution. Approximately following the normal distribution. So there is no much outliers in the process, outliers in the data. And this is a random pattern. It is, if you just connect these lines, it's a random pattern. So it is not in a only trend of increasing, only trend of decreasing, something like that. See, that means residual versus fitted value. So error versus fitted value is in a random pattern. If you see, this is also random in nature. The run error, observe order, and residuals. So how the residuals are with reference to each experimentation. 16 experimentation I have done. So what is the residual for first experiment? What is the residual for second experiment? What is the residual for third experiment? And like that. So residual means error between the experimental value and the predicted value. What does that mean? I'll explain. So what does that mean? I'll explain. So for example, again same regression, the predict. Okay, suppose I want a bore diameter. So it enter individual values. Bore diameter I want X is. I want X is here 130, right? 130 I want X. For a 130 of depth of cut, what is my value of Y? Result will be stored. Regression equation prediction table. Option is let it be two-sided. Storage yes. Fitted fits and confidence interval is not required and say okay. So see, the actual value is what is called as the 35 experimental value, but your model is giving 36.21, isn't it? So actual value is giving, experimental value is giving 35, but your model is giving 36, so like this. So this is how we measure the residuals. Okay, so predict. Suppose if I want 174, for the 174, what is the value? For 134, what is the value? For 191, what is the value? And 165, let take some few values, then I'll compare. 194 as it is I'm taking. Okay, 143, I'm not changing anything, and 186. Okay, we can give the value also 186 and say okay. So these are the values which I got. Okay, so actual experimentation is 35, but model is giving 36.21, isn't it? So the difference of this will be your this. Suppose okay, so if I take these values if I take here in the here, okay, so this is predicted value. This is predicted value. Okay, so this is the predicted value, and this predicted value, if you residuals means it is basically either the actual value or maybe something we can do. If it is see if in this graph, is it taking a positive or negative? Let us check. Yeah, if you see here, it is taking a negative. The first experiment negativity. Okay, the actual minus minus predicted. Actual minus predicted. Actual is this minus this is predicted. It is approximately minus 1.2 bore diameter mm. Okay, like this we can calculate. Say now, this is basically the residuals. So these residuals has been plotted actually in the this graph. This is the residual plot analysis. Experiment number one is 1 minus 1.22. Experiment number two, it is basically approximately how much? 5.59 something like that. No, yeah, 5.6 something like that. Experiment number two 2.66. Experiment number four like that. It has been plotted. So it may again vary with reference to the data to data, right? I can predict even in between values also. If I want to predict in between values, so I should give the in between value. Suppose if I want like this same value, if I predict, I have shown you. Now if I want to predict 132, at what value of 130? 173 and 131. Instead of 132, I am putting 131. Okay, so that's what I want to check. So let's see whether this, oh, sorry, hide I'll do. Okay. And then I'll check the, this, how much it is, 131 hour, 190, 190, 190, I want to know. 164, 162, I want to know. 162, 162, 162. Any values you can find. Suppose it's a 194, 165 is over 194. It is I want to know 190, 91, and I want to know 143 means 140 I want to know, like that, and 186 means 185, 183 I want to know. So these are my values. I want to know these values. At what value of these values x's? So I want to find out the value of y. So these are my x's, different x's. So I need to paste from here actually. Yes. So these values are deleted. So these are my x's. Now I'll see the prediction of this. So here From the column I'll take this x value, I'll take depth of cut and say result okay. Okay, so now you see, I think I already showed all the things. So the fitted value at a 132 is 38 point this, at 173 75 point one thing, one at 131 737, like that, 190 90. Now my question is, my if suppose you take this value, okay, this value. So now at this different x values, I am predicted this. This is prediction values predicted by the equation, predicted values for a different value of x, isn't it? For a different value of x. Now these values, whatever we get, okay, whatever we get from the experimentation will not be same, right? Suppose if I set in CNC machine 132 RPM, depth of cut, mm, then you will not get 38. So this is a predicted value, right? You may get around 75% of that. How much it is? Plus 0.75 approximately. Approximately, you'll get 28 or 30, or approximately 28 or 29, something like that. 29, let us say. Approximately, I'm telling around 80%. So why this? As I was told, no, I was told, right? Approximate prediction capability is how much it is? Approximately. Uh, what was the prediction capability of this predicted row diameter? Yeah, 75.54 only it is, right? The that means 75.54% of the accuracy it will predict. Okay, accuracy it will predict. That means for different values, or even outside of the boundary also. So here you're getting 38, maybe maybe you are getting around 30 or 29 or something like that. Okay, or sorry, even lesser also, even more also. Okay, if suppose here 38 you are getting, means you may be getting there 40 or something like that, 40 or something like that. Okay, actually it's 40 but it is getting 38, something like that. That means what I'm trying to saying is that if the predicted R square is very high, that means you will match the predicted values with the experimental value. If predicted R square value is a bit of less, so you may not exactly match with the values of what we get from the prediction values, prediction equation from the experimental value. That's what I was trying to explaining you. So, and here the coefficient regression, yeah, prediction values it is giving, standard fit and CI as well as PI is given here. For a value of 130, what is the fit value? For a value of 130, what is the fitted value? And again, different values. Okay, for a value of 191, what is the fitted value? For a value of 160, what is the fitted value? Like that, it is given 194, what is the fitted value? So we have calculated here. So for 143, like that. So for 186, what is the value? 86.79, what we got? 86.97 we got. And confidence interval also is given, and prediction interval also is given. Okay, so the confidence interval means 90% chance that your predicted values is in the between 78 to 95 when your value of x1, isn't it? There's a prediction value, confidence interval. Okay, so approximately when you keep around 186 as a x value, 90% chance that your value is between 78 to 95. Prediction interval means, so that means one time you check the 180, 186, you got 86. Another time you check 188, again you will take no, something like closer to 85 or so. Again, when you check 186, you will get 187 or 87, something like that. So you do 1 lakhs population, means sample, different samples you do. You do per experiment, different samples to experiments, and the prediction interval will be approximately 62 to 100. That means on an average, the prediction value from that equation for a different times of the 186 value, you may get the prediction interval is approximately 62 to 111. So this is based on basically equation. So we are talking about the equation is concerned. Okay, we are talking about the equation. This is not from the equation, it is a confidence interval. So when you do repeatedly this same activity, the their value is closer between the 78 to 95. That is the meaning. So so in this case, the correlation value is 0.897. It is basically a positive, and then yeah, R square is 80.41. It is greater than 90, 70% or 85%, 80%. It is can be considered as a good enough on the model. And these are regression p values, regression analysis, and p value is less than 0.05. So depth of cut is a significant factor. So these are the coefficients what we got from the equation, and we have modeled the equation like this. So that is what is equal to minus 81.6 plus 0.90 depth of cut. Okay, and residual plots in Excel also we can plot. Okay, and even Minitab also we can plot. And normal probability plot shows the residuals are normal distributed because all center points are basically peak and when are the tail points. Okay, tail points. So tail point. Okay, so next is 1 minute. I have some urgent office call. Sorry for that. Okay. So that's what we have seen here. The model is accurate around 80%, but still this model can be considered as a good model. Okay. So another linear concept, linear regression, that in this case cutting speed has been taken into consideration. Earlier it was depth of cut, now it is cutting speed. So in the cutting speed means another variables we are taken. But in real practice, the model will not, in real practice, the process will not have only one variable. You have more than one variables, right? Obviously true. In a suppose a CNC machining process, also if I take example as a mechanical example, so you may come across you want to measure as a output as a MRR, but that MRR is not only depends on speed, it may depends on feed, and it may also depends on depth of cut and some other parameter also. Maybe you are having the a factor of suppose MRR is your y, MRR is your y, and this y is not depends on only x1, that is what depth of cut. It may also depends on maybe x2 also, that is called feed rate, and x3 also maybe cutting speed, and x4 maybe type of cutting fluid, type of cutting fluid, something like that, like x4, x5, x3, x6. So there may be n number of variables you may have, or n number of variables may be responsible for y, isn't it? So that means when you are considering more than one variable, then that analysis we call as multiple regression. That means when you are considering the output, the model output is based on the two or more variables, then this model is called as multiple regression. That means in this case, MRR is equal to alpha plus beta into x1, beta 1 into x1 and beta 2 into x2 plus beta 3 into x3 plus beta 4 into x4 and so on. So on will be there. Then interaction also will be there into account. Linear factor also will be there into account. So when there is a model having more number of variables, Then we represent the general form is y is equal to alpha plus beta 1 into x1 plus beta 2 into x2 and so on up to beta k into xk. K is an number of factors. So now in a two variable case, it will be like this: alpha plus beta 1 into x1 plus beta 2 into x2. But here there is a one missing is we are interaction also. So beta 1, 2 into x1 and x2, that we are not considering. If you are considering interaction factor, that is the combined effect of x1 and x2, then the model will be alpha plus beta 1 into x1 plus beta 2 into x2 plus beta 1 into x1 x2. But if you are not considering the interaction into account, only linear things into account, then the beta 1 into x1 plus beta 2 into x2 only will be there in the model. So when there is a more than two variables in the model, then there is another term we have to measure is adjusted R square. As I was explaining when simple linear regression, that time I was not highlighted about the adjusted R square value, because adjusted R square only we need to check when you have more than two variables in the model. Because why is this adjusted R square will adjust the R square in such a way that when you are adding more and more variable in the model, let us say you have two variables. Let us say you have one variable. Let us say y is equal to alpha plus beta 1 into x1. Your R square value will be around 80%. Let us say assume, and adjusted R square will be 79%. Definitely just lesser than the 79.8 or something 9. But when you are adding one more variable into the model, alpha plus beta 1 into x1 plus beta 2 into x2, that means cutting speed as well as feed rate you have added. What will happen? R square definitely will increase, maybe 18, 89, 80 to 89 or 80 to 80, maybe 5, let us, small area. But what about adjusted R square? Adjusted R square not going to increase or decrease. Suppose if that variable is a beneficial variable, it will be increased with lesser than the R square value. Here 85 means it is basically 84. But if that parameter is not an important factor, then adjusted R square will be maybe very lesser. Means that will not significant. Maybe only 85 or maybe 79.9. That will not increasing or decreasing. Okay, that means what is an indication that that variable what you are adding into the model, that model variable will have any effect on the R value or not. If you are adding that new variable and R square value is, of course, it is an increase, but your adjusted R square value is not increasing, then no point of adding that variable. That means what is an indication that that factor is not a significant factor in the model. That way also we can judge the adjusted R square. So that means the adjusted R square always lesser than the R square value. But when you are adding useless parameter, let us say type of the material you have added in your experimentation, there is no user link with the cutting speed, feed rate, and what is called a depth of cut. Type of material, how it is influence the your maybe material, some other Y process time or something like that, or maybe the something like array value or something like that. If it is influence, that is good. But if it is irrelevant factors you are adding into the model, then you are adjusted that information will be indicated or intimated by the parameter called adjusted R square. If the edited parameter or parameter which you added in the model, if it is a value added parameter, then the adjusted R square will be definitely increase as R square increases. Otherwise, adjusted R square will be not increases, it will remain same of the previous one. So if this remains same, then we can understand that that factor is no use for me. No use of adding that factor, because that factor not having any influence on the Y value. So we have to immediately remove that. We have to add another factors. So by doing so, we will remove the many factors which are not influence to the R square value. So that method is called stepwise regression. That means you have initially three factors, and what it does, it will calculate R square value, adjusted R square value. If that x3 factors, first x1 it will add, then calculate the R square value and adjusted R square value. Then x2 factor is adds, it will calculate R square value, adjusted R square value. Then you will see the difference. If by adding the x2 in the model, is there any significant performance on the R square or not? Of course, R square will increase, but what about adjusted R square? If again adding the third, then whether what is the significant effect R square and adjusted R square. So likewise, when you do it, So that method is called stepwise regression. Stepwise regression, where adding stepwise the different parameters in the model, finding the R square value and adjusted R square value. So that's how the concept of stepwise regression in regression modeling. Now we will see one example of again the same example I'll take, that bore diameter and cutting speed, depth of cut and cutting speed are the both are the same example I'll take on bore thickness. This time now I'll take bore thickness data, MLR exercise one, and let us see we'll fit the model. We'll fit the model by using a multiple linear regression this time. Multiple linear regression, why we are telling? Because it has more two variables into account, more than two variables, two or more than two variables. At least two means also we say multiple regression. If more than two and more than two variables means we say that it's a multiple regression only. So again, the similar way, since all are continuous data, then we should use correlation regression technique and scatter plot. Here you can see cuttings, depth of cut is a significant factor from the graphical analysis. And but I want to know at what value of depth of cut is be better for bore thickness. Okay, so then we'll find out the same thing. So we'll take that data MLR exercise 2, sorry, MLR exercise 1. MLR exercise 1. Okay. Or yeah, MLR exercise 1 will take. Okay. So this is the my data. Okay. So when I'll take these two data in the mini tab, so I'll paste this data. So then I'll do the multiple regression now. Yeah. So go to start, regression, regression, fit regression here. Okay. So in this case, what I'll do is instead of bore diameter, I'll take bore thickness is my output, and category continuous variable are depth of cut. Sorry, depth of cut is to be added in the continuous variable window. This is this window, depth of cut as well as cutting speed. Both I'm adding. Two variables I'm adding, isn't it? So that means two variables I'm adding means it's a multiple linear regression model. So now when I'm adding two variables, so it has to give the adjusted R square value also. And adjusted R square value should be differ from the R square value. Okay. When you're adding only x1, adjusted R square value will be closer to the R square value. As we have seen in the previous example, 80.1 was the R square value and adjusted R 79.8 is the adjusted R square. A slight difference will be there. Okay, so then stepwise regression you have to select because let the automatically the linear regression will take into account addition of variables, finding the R square, adjusted R square, addition of the variable, and delete also. If there is an insignificant factor, it will delete automatically. Okay, from the equation. Say okay, and the graphs as usual 4 in 1. I want residual histogram ratio, normal probability plot, residual versus fit plot, residual versus order plot, and then storage you can residuals you can store, fits you can store, and standard residuals is not required. Cookies distance also not required. Coefficients you can also store. That will be there in the session window. If you want, you can store also. So now you can see here. Now you can see that. Now you can see in this analysis result again from the above. This is a regression analysis, that bore analysis versus depth of cut and cutting speed. Now if you see the thing is the things is this is analysis of regression analysis of variance, not the simple linear analysis of variance. It's a regression analysis of variance. So here regression is the model. What is the value? Yeah, p value is exactly 0. That means the model is accurate, highly accurate, isn't it? So because less than 0.05, so then definitely it is a model is perfectly well. Now you can see I was added a two variables, right? One is the depth of cut, another is the cutting speed, isn't it? But the stepwise regression automatically removed. Cutting speed is removed from the model. Why it is removed? It is removed because by adding that cutting speed, accuracy of the model is not was not improved maybe. might have not improved, might have not improved. That is why, that is why so when you are so when you are adding that another variable by using stepwise regression, so it has already removed that stepwise regression, and it is calculated the variable which is important to the model. I want to show you that also. If you are not selected the stepwise, what will happen? Regression, regression, fit regression. I'll not select the stepwise. I'll just only none. Okay, then your model have both the variables. Your model have both the variables. So your model have both the variables in the ANOVA analysis also. If see depth of cut as well as cutting speed, you have the model have both the variables. Now you see the p value of cutting speed. P value of cutting speed is p is more than 0.05. P is more than 0.05. That means this factor is not at all significant. That is why the stepwise regression, it automatically removed. So that is why when we have to stepwise regression means you are not sure that whether my three factors were important or not. In that case, you use stepwise regression, then fit the model, then automatically stepwise regression will remove the unimportant, useless variables from the model, which are not significant for your system. Now, if you addition of x1, x2, although it is 83%, but it is not correct because the influence of x2 is having here. But when you remove this factor, when you remove this factor, by addition of the factor, 83 is getting. But when you remove this factor, definitely your y value, r square value will not be 83, it is 81. Because that influence of that x2 factor is removed from the system. Okay, because addition of that factor does not have any impact on the y accuracy of the model. So by adding the x2 you may get accurate 82, right? 83 you will get, but 83 will get. But what does that mean? The r square adjusted as 80.93, and here if you see 80.17, there is no change in the adjusted r square. I repeat again, when you are adding the one more variable, R square will increase. Accuracy of the model will increase. But what about the adequacy of the model? Adequacy of the model will not going to increase anymore. 80.17, here also 80.97, slight variation. That's all. That means there is no change in the adjusted R square. That's what I was trying to explaining in the PPT. When you're adding go on variables, R square will drastically increase, but adjusted R square will not going to increase unless that factor is a useful factor. I mean, it's important factor. In this case, if I add or not add does not matter for me because its adjusted R square is same. So therefore, we have to remove that model. Why we have to remove the that factor? Because its p value is also more than that, more than the 0.05. One is more than 0.05, and by adding that x2 factor in the model, my adjusted R square adequacy of the model is not improving. Accuracy is also very less improvement. 81 minus 83, 2% only it is increment. That is not considered as a good improvement, right? So therefore, we should use the stepwise method to automatically detect the variables, and it will add the variables which are useful to the model. And this is the correct model, and the R square value is 81.9, 81.49 now. Now R square 81 point means it is good model, a reasonably good model, and adjusted R square 80.17, and of course predicted R square is 77.59% only. And the coefficient is given here only because one variable is removed from the model, so therefore only one variable in the equation. This is the correct equation. Suppose if you ask me why this is not correct equation where I'm considering x2 also, no, it's wrong, because this factor is a negative factor, is a negative differential on the y. Although the coefficient is 0.14, that unit of effect of 1.14 is negligible on the y. But generally in research, what we do is we consider the entire factors and will fit and will explain the result. But that is okay, but it is appropriately, it is not good method to do so. So what we need to do is you have to take correct model. So when there is no much influential, that negative influential is there with a point with a coefficient of factor of 0.145, keeping in the model, removing in the from the model is not much difference you will find. So therefore, what we need to do, the model will be this only. 30 minus 36.2 plus 0.7021 into depth of cut. So this is the bore thickness value, and the coefficients are this. Similarly, if you see this again the same, the residual plot is yeah. See the all the three these are closer values. No, these are the what is this? These center values are very closer to the peak value, isn't it? Because normally distributed. You see, this is a data is normally distributed. This data is normally distributed, right? So the peak values are in the closer values, means all the lines are all the data points are peak in the center point, and the remaining tail points are these are the tail points. So there is be minus 15 and 10 and all. So residuals also normally distributed, and the probability plot shows that all the data points are closer to each other, fitted line. These are random pattern, and these are the run orders of the data set. So the conclusion here is we can conclude that again the depth of cut is the root cause or important factor in this analysis also. Say for example, if you see here depth of cut correlation. Correlation I have not shown, okay, correlation we can study. Yeah, if two factors are there, correlation we can study also, that also possible. So for the correlation, we have to go to basic statistics and correlation, and this time I will find the correlation between depth of cut and bore thickness. Okay, and all together also we can do. That is also possible. At a time also we can do depth of cut, cutting speed, and bore thickness. You can see this graph, cutting speed versus cutting speed, the cutting speed versus depth of cut. So the minus 0.00, we should not compare the x versus x, we should compare the x versus y. So the cutting speed versus bore thickness is 0.907, and then another one is what there's a depth of cut versus bore thickness is zero point 0.9, and cutting speed versus bore thickness is what is called minus 0.147. Minus 0.147, that's what it is came here, minus 0.145, right? Minus 0.145, that's what we have got approximately. Not sometimes may not be same also. So negative correlation it is, very least negative correlation, very strong correlation with the positive. Okay. So correlation also we can study. Then we can study the prediction also. We can study the prediction of response optimizer also we can do. At what value of x I should consider in my model so that I'll get the value of y is appropriate. So that is also possible. So there is bore thickness is my output. Bore thickness should be always a target. If you are keeping as a target, if you are keeping as a you want optimizing, you want to bore thickness, you want what is called as the target value. You need to keep a target value, or you want maximization. You want maximization, you keep maximization objective function. More thickness is minimization, you want minimization you have to do, and then go to setup. The setup is as usual same, and go to option. So here are cutting both. If you are taken, then I have to do once again that stepwise regression, then followed by that, because it is taking the previous analysis. Stepwise I have to do. Yeah, stepwise I have to do. Okay, okay, and then I have to go for prediction. Okay, then here it is, I'll be putting maximization option. Here constraint, how much constraint, constraint to the region, yes, what level of lower value, what level of upper value. Okay, so you can find out from that lower value, upper value from the data also. What is the minimum value of the cutting depth of cut or cutting speed? Depth of cut. So what is the minimum value here? Minimum value I'll calculate. Minimum value is much lower range I'm talking about. Okay, minimum value is this, maximum value. So maximum value is this. So that is 130 and 194. So 130 is my lower value and 194 my higher value. Okay. Then starting value if you want to set, if you can set the starting value above that only I want like that. 95% confidence interval, two-sided limit and say okay. And result you can store how many solutions you want. I think three or four solutions, or maybe three solution is good enough. Means you are saying that search a optimal areas of three solutions. That's the meaning. And storage not required, and view model, yes, the model is required, and say okay. Now you can see this the results. Although I have given three solutions, but it is only giving two solutions. That means for this model, only two solutions is available under the constraint of 130 depth of cut to 194 depth of cut. Now it is showing that the if you keep depth of cut 194, then bore thickness will get 99.99999 and desirability value is 1. If you keep 191.162, you will get 98 point. These are the possible combination where I can get the maximum bore thickness. If your target is maximum thickness, but if your target is minimum thickness, then the scenario will be different. If your target is a target value, then scenario will be different, isn't it? So that means it is calculating from that entire working space, surface and optimal value. At what value of x1 value will get the optimal value of bore thickness, that is your output parameter. Okay, so desirability is only one, but although I have given more three solutions, I asked the Minitab to give three solutions, but it searched the optimization under that surface of region, and it has possible only two solutions is available. One is you keep x1 is 194 in the machine, you will get 99.99 as a bore thickness. If you keep 191.162 in the machine as a depth of cut, you will get 99 approximately. It is an approximate 98 point you will get. May not be guaranteed that you will get exactly 98. You may get 97.9 or you may get 98.1 or you may get something like, because the prediction and actual will have the difference, because actual have many number of noise, environmental factor, operator mistake, machine vibration, machine fluctuation, wrong setting of the factors. There are many reasons noise will be there, due to which there is a fluctuations will get. So that fluctuation should be within the within the limit. It should not be crossing the limit of the system. Okay, so this is how we basically do the multiple regression, and we can predict also what value of x you will able to find the value of the output y. Okay, so that's what it is done here. So in this case the r square is there. So here r square is 83.46 is got. Okay, by considering both the factor, and greater than 70, greater than 70, so we can say that model is adequacy is there. So here both the we have taken here, we should not take, but both the model is taken. If both the model is taken, the equation will be like this, and both the variables is taken. Okay, but in general practice we should not take, we should not take, we can remove. Ultimately we are removing the variable which is not responsible for the, not responsible for the system, not responsible for the system. Okay, so this is how the multiple regression will help in taking the decisions. Okay, so we can predict also. Let us take this one more example. I'll show you how this Indian Oil Corporation has used the concept of multiple linear regression to predict their price of the cutting fluid, sorry, price of the petrol. So let us this real data it is. So the Indian Oil Corporation Limited want to improve the sales of the gasoline weekly basis. That means they want to improve their sales. And during the analysis phase, sales manager identified two potential causes. One is weak and price. That means either different week, Monday first week, second week, third week, fourth week, or the price of the gasoline price. If I increase the price today 90 rupees, tomorrow 91.5, 90.5, is there any effect on the number of sales of the petrol or the gasoline? That's what they want to know. So let us see the data first, how it looks like the data. And the data looks like this. So the price of the gasoline and week number is there. First week, second week, third week, fourth week, fifth week, sixth week, tenth week they have taken. This is a very small data I have taken, but in the petroleum industry, they have huge data of maybe 10-year data, maybe last 1 year data, day-wise data, monthly-wise data, weekly-wise data they have. So, but for hypothetical case, I have taken only 10 weeks data from that industry, and then price they have kept 1.95 per gallon, 2.2 per gallon for the second week, 2.21 for the third week, 1.98 for the fourth week, and that like this they varied the price of the gallon. Even today's scenarios, if you see price of the gallon price or dollar price is increasing, no, increasing or decreasing. So week wise it is increasing, and how much quantity of the gasoline is sold is also is there with them. That means first week for a price of 1.95 per gallon, 10,420 liters of gasoline is sold, like that. For the second week, 2.2 price per gallon, 7,388 liters of gasolines were sold. Let us see, we'll fit the model and we'll see which factor is important, how we can predict, and all those things possibility can be analyzed by using the multiple regression. This is the beauty of the multiple regression for modeling the process and taking the conclusion of the about the system. So as usual, similar way, start basics, regression, correlation we can do. Yeah, correlation, and in this time it is all three together, and say okay, okay. This I need to remove first and then add week, gasoline, and price. And see here, the gasoline sold is your output. Week, yeah, week versus gasoline sold is a strong relation, 0.827, and gasoline sold versus price also strong relation, but negative relation. That means there is indication that when the price is increasing, gasoline sold is decreasing, or when gasoline sold is decreasing, price is increasing. That is a negative relationship. That is the meaning. That is a meaning. Okay, then we'll go to start regression, fit regression, and this time is gasoline sold is my output, and continuous variable is week and price. Let us take both the variables, and I'll tell the WinTab that we sort out yourself, something like that. Okay, say okay, and the graph is same 4 in 1, and the storage is residual fits and the coefficients. Okay, say okay and okay. So now if you see the result, so the result is looks like this. Analysis of variance. Yes, weak is also significant factor and price is also significant factor. That is less than 0.05, isn't it? So therefore, when I ask this stepwise to do the analysis, it has done the stepwise regression, and it has feel that weak is also significant factor and price is also significant factor for this gasoline sold example. So because p value is less than 0.05 for a week is a x1 factor and price is a x2 factor, isn't it? So, so in this way, we can conclude that the factor of week and the price are both are significant. Now the R square value is good, 85%, 85.70. It's a good enough to state that the model is accurately good, or not reasonably, it's a good, strongly good or accurately good. If you have been 92 and all, it is very higher accuracy, but accuracy is 85% here, and adjusted R square also 81. Always adjusted R square less than the R square value. Okay, and but prediction is only 70% accurate it is. Okay, but yeah, sometime it may varies also, but it may also possible that R square is high, adjusted R square is high, but R square is low. That means you should not use that equation for prediction purpose. That is the meaning. But if your R square value, adjusted R square value, and R square prediction also is reasonably good, then I can use that equation for prediction. The coefficient is got here, That is gasoline is equal to 47,767 as a alpha plus beta, that is 640 into week minus 19,558 into price. That means alpha plus beta 1 into x1 plus minus beta 2 into x2. Beta 2 is basically negative relation. Beta 1 is a positive coefficient. Isn't it? Positive coefficient it is negative coefficient. That is an indication negative correlation, and it is a positive correlation, something like that. Okay, and then fits and diagonals, observe 10 observations, gasoline sold and all, we can find. Residual plot also, if you see, residual plot also shows the same condition, that all the data set points are closer to state line, closer to state line. So it is an indication that your model is highly accurate, and all residuals are normally distributed. Okay, normally distributed. So that we can check by using the normality test also. That's what it is checked actually. Normal probability plot, whatever you're able to see here, it is basically normality test only. It is normality test only. Okay, and the histogram, if you just draw a simple fit curve, it is something like related to the normal distribution, but some values are out of the family kind of thing. It's not a out of family, but some data are bit kind of outside of the region, isn't it? This region, this whatever I'm talking about, 3,000 something like that. So it is something has happened that particular week. It is drastically the 3,000 was the is increment is happened, something like that, or so selling was the different from the other weeks. That is the meaning. And the trend is a pattern is random in nature. It should be random in nature always. It should be random in nature. It should not be what is called as the any trend like increasing or decreasing, something like that. Residual should be always a random in pattern. Then only we say that the model is a correct model. If the residuals, fitted residuals is not in random in nature, it is something have a trend or pattern, then we should definitely that we can visible by using R square, adjusted R square, and p value of the significant factors and all, that can easily tell us that the model is not a accurate model. And this is just a run order or observation order residuals, each of the experiment, or each experiment how much residual it is, that is showing. This is just only the consistently the residuals is a consistent is there. Okay, not too much high now, not too much low, like that. It is consistently the residuals is differentiating. That means that prediction or accurate model, no, 85%, that is why it is consistently the residuals are there. Okay, plus minus plus minus plus minus plus minus plus minus, something like that, consistently it is producing the results. So we can predict also. Now I want to predict the, for example, I want to predict the for the what is called as the same values. If I want to predict the same values, what is the predicted value, let us see. Okay, so the actual prediction is experimental data it is. Now what is the prediction, let us see. Because of that accuracy of 85%, no, there is a chance of difference. So for prediction, regression, predict, in this time predict. Then I want in the columns, so the week and price. I want to predict both. Yeah, you can give the week, okay, and prediction price also. According to this week and price, predict the value. Okay, store the value, predicted value, standard error. I don't want confidence interval. You want, you can confidence a prediction interval also. You have the prediction that I don't want for the time being, or you can for this it is not required, and say okay and say okay. Now you can see this is a fitted value. So now, what it does is, what it is giving information is, so this is your predicted value. Uh, yeah, this is your predicted value. So I'll paste here. So this is your predicted value. Okay, this is predicted value. So predicted value in the sense, this is from the equation, this is from the experimentation. Now you see the residual. Residual means error. That is error. Actual minus predicted. So still there is a difference. It is there. 150 liters dollars is difference. I mean residual is approximately it's not same. At if I'm keeping 1.95 per gallon first week, my actual sold was 10,400 liters. But prediction model saying that 10,268, isn't it? So there's a difference is there in the model. So no, that is why because it has some error, noise, and all factors, biasness, variations is not much accurately captured here. Isn't it? 85% only it is captured. So remaining 15% is not captured. That is why this difference is getting. So if your R square value is 98, that means 2% variation is not captured, and 98% time 98% times the variation is captured. Actual variation is captured by the model. Here still 15% actual variation of the actual experimental variation is not captured by the model. That is the main. The reason maybe could be the kind of way you have collected the data, how you have collected the data, and who has collected the data. So all those things, root cause will come. That means that are the factors which will affect the capturing the variation of actual variation of the by the model. So that is all depends on how you have collected the data and how accurate the data is, and that affects the your accuracy of the model. So here, even though 85% is considerable reasonably good, but your prediction value is not exactly matching with the actual value. So that is why always their error will be there. That error prediction error will be there. That prediction error uh, should be as less as possible. That means capturing a variation should by the model should be as more more as possible. Variation should be captured by the model should be more. So I can predict the now for the 11th week also. 11th week what will be the my because I do not have a data, I don't want to do experimentation, but I want to keep the price as let us say 1.9 only. If I keep 1.9 for the 11th week, what is the approximate value of gallons of gasoline will be sold, that we can predict, so that he will get a judgment that okay, next week how much quantity of the oil I need to buy and I need to store in my inventory. That is the he can get that particular person will get to know, okay, so the next week I need to keep this much of gallons of the gasoline, so that expectedly that much of selling will be happen. So that way we can predict. Let us say we'll predict at 11th week at 1.9 price of gallon, how much is the gallon will sold. So that we can do in the prediction also. Regression predict. And now this time what I will do is I'll put the week number 11 and price is I want to put only 1.9. Or week number 12 I'll put the value of so let us say 1 point suppose 2.2 highest value I'll keep 2.2. If I keep 2.2 price, what is the amount of gasoline approximately will sell? And 13th week if I keep the price is at 1.98 or 2.01, if 2.01 if I keep, what will be my value of gasoline sold? So that I want to predict. So now if you see here, so for a value of 11th week, for 11th week at a price of 1.9 dollar, then approximately 70,649 liters will sell. Liters will sell. So approximately this much of liters will sell. So this is I don't know from the experimentation, but from the model I got to know at for the 11th week how much inventory I need to store. Approximately, if you are keeping the price is 1.9, approximately 17,649 liters of gasoline you should keep in your inventory. Otherwise, if you are not able to keep, then the demand will increase and the supply will be very less. Then the again issue will come. So therefore, this gasoline industry will analyze like this by using linear regression, that what is the amount of quantity of the liquid I should keep in my inventory so that on the 11th week when I'll be come to know the customer will take or this much of quantity of liters I should keep in my inventory. That is the way the what is called as the regression will help. If it is 12th week with 2.2, so what is the amount? This is the amount total liters of liquids will be sold in that week. So if you see what is happening here is, so it is 2.2 price I'm keeping for the 12th week. Now you see, for when I'm keeping 1.9 as a price, more number of gasoline sold quantities more. When I'm increasing the price on the 12th week, it is approximately selling is only 12,422. Now you see the difference. So as the price is increasing, what is happening? Maybe chance of selling is decreasing. It is also true also in real practice also, no, when price will increase, the gasoline sold selling of that particular fuel is also quite be less also. When price is less, the selling will be more. Now if you see the 2.1, if I'm keeping the price 2.1, what is the amount of is selling of this gasoline? So here it is again, it is increased again. I have reduced the price, and then if you see the when I'm reducing the price, so what is happening is it is 2.01 when I'm keeping the price on the 13th week. So I'm increase the number of cell. So here you can see this, the influence of the price on the week on the selling of the number of liters is influencing, isn't it? So therefore this way a person or the that industry, that oil person can take the prediction and he can make the inventory is full as per the price and number of weeks. And even this, it also tells if you're keeping 2.1 as a price and 13th week, what is the limits of the gasoline will sold. It isn't exactly, it's an approximately 16,778. But what is the chance that it exactly, what is the chance of interval of selling the gasoline when I'm keeping the price is 2.01 and the week number is 13? So the chance is 12,114 liters to 21,442 liters. That means he'll get a judgment that I should keep quantity between 12,114 liters to 21,442 liters, so that I can fulfill the demand on 13th week when I'm keeping the price of 2.01. This is how the statistics will help him to take the decisions and make their business will be successful. So that's how the multiple regression is concerned. Any question in the multiple regression? Let me take one or two questions. Even we can find the optimal also. Here also we can find out the optimal regression and optimal response. You want to gas oil cell should be maximized. I want to maximize the gas oil result, and the options we can give a weak and as well as the constraint of the region, and it is basically constraint to the region. So the lower is constraint is 1 to 10. Here it is 1 to 10 is my lower is upper, and price is between how much is minimum. Minimum is I can predict between 1.82 is minimum, and 2.3 is maximum. Approximately we can do 1.8 is my minimum, and 1.82 it is telling 1.82 and 2.2 it is saying. So okay, okay, and say solutions I want is around three solutions. Okay, okay. If you give the solution, it will give the solution that. So how many solution it has given? Or three solutions it is given. Yes, the highest solution is week number 10. If you keep price number 1.82 per gallon, then highest sell will be possible. But if you're keeping 2.01, then in the fifth week you may get the this much of selling of sold. So better the desirability function which is having more closer to one, that solution we have to take. So this is the optimal solution for this problem. So 10th week, let it be week. If you keep 1.8 as a price per gallon, in most of the cases, you will find the selling of gasoline sold will be higher and higher. But if you are increasing, decreasing this 1.8 value, there may be chances of increasing or decreasing the what is called as not increasing, maybe decreasing only most of this is optimal value. Maximum value, minimum value different compared to the optimal value. Optimum value means In most of the times, if you do that price of 1.82, in most of the weeks, if you continuously keep 1.82, 1.82 for next three weeks, you will find that the optimal number of liters we can sell from your unit. So that is the meaning. But maximum is different and minimum is different. And here it is maximum 18,573 per week we can sell the other gasoline. So this is how the linear regression will help in taking the decisions, not only in the business, even we are doing the analysis of research also in the research paper also, when we are collecting the data from the field and do the correctly analysis and represent that analysis in a better way. So any question up to here?
Participants, any doubts, any questions?
So if there is no question, then I'll move to the another the next phase. That is the analyze phase is over now. Analyze phase means we identified the root cause of the problem. In the measure phase, we identified only why. We have measured the different parameters. Now, in the measure phase, we have identified what is the sigma level. Then we found that there is a less output in the Y. I want to improve the output. For that, what are the X's we identified? And we found that which X's is important and what value of X is important for me. Now I have to improve it, no, because I know the solution. I know the solution that at if a price is 1.82, then I'll get the more selling. Then I got the solution. I have to improve that. I have to implement in my real practice in the process. That means that gasoline industry has to implement that 1.82 price they have to keep for the next 3 months, 3 weeks. Then they will. That is the implementation. That is what improve. So in the improve phase, what we do, we identify the solution and we will implement it. So identifying the solution and validate the solution and implement the solution. First, identify the solution. That means finding the optimal result. Validate means same optimal setting will kept in the machine. Re-experimentation we said, no? Confirmatory analysis, something we do in a research area, academic field. Confirmatory analysis, something like that we do. That means optimal setting you got from the solution, and that is that identification of the solution. Then validation means that means confirmatory analysis. Same optimal setting again you will set in the machine, and we will do the one more experiment, and we will see that whether it is got the same result or not. If it is so, how much improvement is done? That implementation means after implementation you will see that initial MRR is how much. Now improved MRR is how much. Initial process time is how much. After implementation of the solution, how much. Like that we will compare. That is what improve phases we do. So in the improve phase, we will be possibility of finding the three possible. One is a single solution you may get. That means for that problem only one single problems. Okay, this is the problem. Okay, cutting speed was the problem, and then the solution is set the proper cutting speed value. That is a single solution. For the same problem, you have multiple solutions also. One is operating the conditions, optimal setting. Another is maybe cutting fluid change. Another maybe operator change. Another maybe vendor supplier change. So all the different solutions are there. When you have multiple solutions, then we have to choose which solution I need to implement that gives you optimal result for me again. So that is also very important. Even one single solution is there, optimal setting of this cutting speed will give you output good, then you will immediately go for confirmatory analysis and get the result. But if you have multiple solution, you have to find out the what is called the which one is that. Or sometime you may feel that I'll implement all the multiple solutions in my process so that my process will be better. And if no solution at all, also possible. You found you have put everything effort, collected the data, analyzed the result, and then you find the model is not at all good. That means model is not a accurate model. Is everything is waste. No solution is found from the model. That is also possibility will be there. There is a high risk. If there is no solution, there is a high risk. If there is a solution, it is a good for the business. So single solution means pilot the solution, means pilot experiment you do, validate the result. If satisfactory, implement for the full scale. Generally in industry, what they will do, no, they will not take a risk. So you got a solution, you have a problem, you have find a solution, and then that solution they will not implement in full scale, because it may possible that that solution may not after from the analytical model it is giving a good solution, but what is the guarantee that that solution will be practically also it will give good solution? That we do not know, right? I'm giving a offer that get one free and buy one get one free. There's a strategy I want to implement, this is a solution, but I do not know whether it will work in the real practice or not. So what they will do, for a small batch they will implement that. For a small mahal they will implement first that strategy, buy one get one. If more response is getting, then they will implement for throughout the India, throughout the branches, throughout the franchises. So that way it is we do in our industry also. Pilot do, we'll do the pilot solution, validate the result. If you got satisfactory, you get a confidence, then implement for the full scale model in the entire this. If multiple solution is there, then rate the solution, which one is prioritize now. Suppose there are three solutions you got, now which solution I need to put first, which solution I need to apply first. Rate the solution, choose the best suited one, pilot the selected solution, validate the result, and if satisfactory, implement the solution in full scale, followed by other solutions also. So if you have n number of solutions, so these are the ways by which we basically improve our system, improve our process, right? Improve stage only that only we do. Find the solution. If multiple solution is there, a weighted solution method we apply here. Rate the solution, which is rank number one solution. You implement that. That too in pilot scale, not the full scale. Satisfactory we get, you implement. Otherwise, go for the second solution. That is what we do in rating the solution. Solution A, solution B you got. Suppose you have three solutions you got. Then you see solution A is better for customer, it is better for management, it is better for employee. You should not implement such a solution which is hindering to the customer. That means customer is not liking that, and management is also not liking, because to implement the solution you require more number of cost, okay, more number of resource you require. Then management says no, not no issue, don't implement that solution, because ultimately management has to give us amount to you in extra. These are extra activity you are doing in addition to the regular activities in industry. So it should not hampering on the employees also. No, employee will not feel that critical to employee also should not be there. So solution should be in such a way that it is customer should be satisfied, management should also be satisfied, and employees should also be satisfied who is working on that. So therefore we have to rate that how much satisfaction of the customer, management, critical for all the solutions, and you will find the overall rating. If it is 3, it is 2 and 1 means the first solution is better here. So that means I need to select the solution 1, a solution A, and I have to implement it. Okay. So one is worst, 5 is moderate, 10 is best, something like that. So the customer, critical to customer means improve the performance measures like defects reduction, various reduction, yield improvement and all. Management means reduction in cost of implementation. Employee means reduction in additional work. Okay, he should not feel employee that why should I do additional work? I will not get any extra money. So reduction in additional work also is plays very important role. So I should not hamper the employee also. So overall rating should be high. The best solution is one with highest overall ranking, and that solution to be implemented in the real practice. So this is all about the improve phase. Then we will see the control phase in the after the lunch. Any question up to here? And this is the last phase of the Six Sigma Yellow Belt journey.
Any questions, participants? Sir, I think only one question was there that you have answered, it seems, in the chat box. Sir, how to calculate fitted value similar to residuals? So,
How
by
to calculate fitted value similar to residuals?
fitted value is a theoretical value. You get it by regression model. Yes, am I correct, sir?
Yes, yes, yes.
Yeah. So
When we will
the
get this sessions recorded link? Okay.
yeah, I'll share it. And
Okay.
fitted value minus actual value will give you the residuals.
Residuals, yes, yes. Fitted
Yes,
value
sir.
is nothing but it is a predicted value. Then actual value is the experimental value.
So one doubt, sir, like whatever linear regression you mentioned about, simple linear
Yes.
regression or multiple linear regression, is it to the same what we use it in machine learning also?
Yes. 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 So
Okay.
in the machine learning is bit of quite of advanced, but it is similar only.
Okay, sir.
Because
Okay.
in machine learning also we use a machine. One is classification and regression. There are two types of machine learning.
Yeah. Yeah.
One is classification means support vector machine, tree method and all, where it is classifies. Another part of the machine learning is regression. That's what it is a regression I taught.
Yes, sir. Yes, sir. Yes, sir. If no questions, then we'll meet after lunch. That is at 2 p.m. All of you are requested to join back on time, please, so that we can wind up the session on time. Thank you. If any other questions are there, you can ask at 2 p.m. also, not a problem. And recorded links, I'll share it as soon as FTP gets over, or this Six Sigma entire thing, I'll share it. Like all these 3 days, I'll share it today itself. Thank you. You can leave the meeting, all of you. You can join back at exactly 2 p.m. Thank you.